everyone, in this video I'm going to be working through this paper 1 from 2019. I'm just going to be looking at the algebra questions for today, so question 1 and question 2. If you have any questions, please feel free to let me know in the comments. Okay, so if we look at this first question, we've got lots of factorizing questions. Okay, so factorizing, you've got to play around a little bit. You're either going to factorize by taking out a common factor, by using quadratics, or by looking at dots, so the difference of two squares. So if you kind of have a quick look at this, this first one, we can see all we've got that's in common in both of these is we've got y in both of these. So for this first one, we're going to be factorizing by taking out a common factor. What that means is we divide both of these terms by a common factor, put that on the outside, and then we put what's left in brackets. Okay, so if we say both of these, we can divide them by y. So that is our common factor. So we put y on the outside. We just need to figure out then what's still left. So 3y squared, if we divide that by y, we're still going to have the 3. And then this y squared and the y, with our exponent laws, we're just going to have y left over. And then if we do it on this side as well with this term, y divided by y, those are just going to cancel. So we're just going to get 1. And that is as far as we can factorize that one. So it's just we take out a common factor of y and we work out what's left. Okay, so this one we cancelled that square and we cancelled the y. That's why we have the y left. If we look at the second one, 1.1.2, your hint is as soon as you see an x squared, you've got to be thinking about, is this a quadratic equation? Okay, in this case, it is a quadratic, so whenever we factorize a quadratic, it's always going to be factorized in this form. You're going to have two brackets. This x squared, you're going to have just x in the front, so the square root. And then what you've got to look for is then you've got to read it going backwards. So we've got to go factors of 24 that have a difference of 10. Okay, so that's how we read it. So what we do is we list our factors of 24. So factors of 24, we could go 1 times 24, 2 times 12, 3 times 8, 4 times 6. So we list them like that, and then we check which one of those have a difference of 10. So if we look at these two, 12 take away 2 gives me 10. So those are the ones that I'm going to use. You just put those factors in here, so we can say 2 and 12. And then the only tricky thing you've got to look out for is to make sure you've got the right signs. So if we look at these ones here, we know it's going to be different signs because we've got a negative and a negative. So that means we're going to have different signs. I would just plug it in and then try figure out what works best. So if we say this one is minus 2, this one is positive 12, what we then do is we're going to try test it out, see if we get back to this original equation if we multiply out. So let me just get some space here. Okay, so always the opposite of factorizing is expanding. So if we can expand and get the same answer, we know the signs are in the right place. So x times x is x squared. X times 12 is 12x. 2 times x, or minus 2 times x, is minus 2x. And minus 2 times 12 is going to be minus 24. We can simplify a little bit, so that's going to give us x squared. 12x take away 2x is positive 10x minus 24. Okay, now we can see we don't get exactly the same expression. We wanted to have minus 10x, but here we've got positive 10x. So it doesn't matter. All that means is that we just got to change these signs around. So in here, instead of a negative, we're going to have a positive, and we're going to change that one around. Okay, so if we get some space here, we're just going to write our final expression when we factorize is going to be x add 2, x take away 12. And then if you did go through and expand it just like we did up here, you'll see we'll get back to this original expression. If I then have a look at 1.1.3, so let me get some space for that one. Again, it's a little bit of a guessing game to start with, how you got to factorize it. This one, we've got that 9x squared. So already I'm starting to think it could be some factorizing with quadratics because we've got the square numbers. And then I've got all these y's and that. So it took me a bit of playing around with this one. what I would say is we factorize this quadratic first. Okay, so just leave the 9x squared for now. We'll get to that, see if we can do anything with that in a bit. Let's factorize this quadratic. So I'm going to put it in brackets just so it's easier to see. So let's put the minus there. The only thing to be careful of is now we've put a minus on the outside of the brackets, so we just need to check. So minus, we wanted y squared, so that would work out minus y squared. A minus times a positive, so we want minus 10y. And then a minus and a minus, so we want positive 25. Okay, that's just making sure that when we multiply, or if we get rid of these brackets, we still got minus y squared, positive 10y, and then negative 25. So that's exactly what we wanted. We don't want to change the equation at all. Now we can factorize this quadratic in the brackets, just like we did in 1.1.2. So if we factorize that, we keep in that 9x squared. And then this quadratic, we know it becomes 2 brackets, okay, with y in the front of both. And now we have got different signs, which means that we're going to have the same signs in here, and they are both going to be negative. And how we've got to read this is we read it from the back. So factors of 25, let me just highlight this, factors of 25 that add up to 10. So that is what we are looking for. So we're going to list our factors of 25. So 1 times 25 or 5 times 5. And we can see those two, that 5 and 5, they add up to 10. So those are the factors we're going to be using. And we can just plug it in here. Okay, much like we did in the one before, you can multiply out and check that you get back to the same expression. This one will work. We've got to keep going. We're trying to factorize it, so it's not looking super factorized yet. But let's see what else we can do. So if we look at that y minus 5, y minus 5, these are exactly the same. So we could, instead of writing it twice, we could write 9x squared minus y minus 5. And we could just square the bracket, okay? Because that's the same as writing 2 brackets. And now, I know it's been a bit of a process to get here, but we actually now have the difference of 2 squares, or dots. Because you can see this is a square number, and this is a square expression. So we can now use dots to factorize that. So how dots works is we take the square root of this one. Okay, so the square root of 9x squared would be 3x. And we put it in the front of 2 brackets. Then we take the square root of this one. Okay, so if we square rooted this bracket, it's just going to be the bracket without that little square up there. So we're going to have y minus 5, y minus 5. And then we add one of them and we subtract one of them. And that is actually as far as we can go with this one. So that is our final factorized form. If we look at question 3, we've got quite a few solving questions to start with. So we have first of all, we've a lot of simplifying. We need to solve this equation, this equation. So simplifying 2x squared minus 10x
usually we need to try expand.
So what I would say is we want to try to see what rules we can use. Whether it's one way I can see we could do this is we could take out x as a common factor here
to try cancel as much as we can.
We could say x is a common factor.
So if we look at this first one,
we've got 2 brackets here. So your hint is as soon as you see brackets, we know we've got negative 10 in that one. So what I would do is I would say
0.
Use that.
And whenever you have something like this, it's kind of an ideal form if you get it into something like this. So if you have
we multiply the first one,
something
4 times 2
something
is just going to be 8,
and it's equal to 0.
Then means that either
the outer
one,
so
first one is 0,
and this
or
fraction
the
of the
second
outer
term is 0.
Okay, so we can say
here
in this one either x is 0,
so minus 12,
okay, which is pretty
over
straightforward.
X. So either that part's 0.
Then we do the inner ones,
or this bracket
so
is
that's
0.
just these two.
So we have 2 solutions to this one.
One over x,
so we can say then
2x
2 over x
10 is equal to 0.
And then finally we're going to
so we've already solved for x in that case.
Last
so we can
ones.
say okay, so x
so
could be 0,
and
or
this
if
one.
we solve for this one,
so 1
we're going to
times
get
3
2x is equal to
positive
3.
10.
So
and
x
is
times
equal to 5
is x.
Okay,
so
squared.
x either equal to 0. Okay, it's looking a little bit better. We've got rid of the brackets, so we're making progress.
In
what we then got to do is try see which these we can add up, how we can simplify it a bit further.
What I would say first of all is let's try to take out x as a common factor.
We can't do much with this 8.
Okay, so if we get x outside,
it's only
we are left with p
and we can't do much
k,
with this 3 over x squared. It's the only one that's got x squared in it. So all we
then
can
I would
do
say we
is
want
add
x by
those two
itself.
middle
When we're
terms.
solving for x, we want it all by itself. So
we're going to
take that bracket across. So we're going to get k minus
we
p
can work out
over
these two.
p minus k. And then I would say to try cancel it, if I want to try get,
so that will be
so I would want
that's
k
fine.
minus p at the
so
top
we're just going
and
to
the
have
bottom. That would be pretty useful.
negative 12
if I want that,
will give
what I can do
negative 10
is I can change the sign
x
of this bracket,
and then we
so I
still
could
got that
rewrite
last
it
fraction.
as k minus p,
and that is actually as far as we can go for that one. So
k
that's our 2 marks. So it's 1 mark.
So that's what I need to do. If I
want
to change these things around inside, I need to put a negative on the outside.
Simplify this part and get this final
That then works out pretty well then, because we can actually cancel. So k minus p will cancel with k minus p, and so we are left with just negative 1.
2.2. What we've got there is again a fraction.
2.1.3, we can see we've got exponents going on. So as soon as we see exponents,
kind of the same thing. If you've got a bracket, you want to try to get rid of it. If you've got a fraction, you want to try
some space
see if you can get rid of it or cancel anything. The first thing I can see here is I would just try and sort out this top here, because at the top we've actually got a common factor. They tell us,
so I would take out 5 as
2
a common factor
to the power of x,
and then we've got
3
x minus 1 left
is equal to 1
over
over
5x
128.
Doesn't do a ton, and
so
I know
what I would do,
like
as soon as I see
now
a base of 2,
I want to try and get whatever numbers I've got on the other side.
This is going to be as far as we can go. So at the top we've got x minus 1,
128.
We've got x.
We can
that
rewrite
is as simple
that.
as we can take
that
that
one.
We
haven't cancelled the fraction,
but we have
rewrite that
managed to
as
cancel
1
5.
over 128. We can say that is
the final one we've got is 1.2.3. And this one
to the power of 7 will give us 128.
Exponent one that you're going to have
then
to
we can use the exponent law. So if I take this
exponent
to the
for
top,
that is because
we
just got a lot of exponents going on. So we're going to try.
So I can say instead of having
exponent laws at some point,
1 over 2 to the power of positive 7, I can rewrite that as 2 to the power of negative 7. Okay, so that's one of the exponent laws
what
that
I would do first, if I see
we're in a pretty good situation,
I want to try. So if we've got it at this form,
so 2,
I'm going to just try rewrite some of these. So for example,
2 to the minus
this
7.
One here, this 3
what we can then say
plus 1
is when the bases are the same, we can assume
3 to the
x, the tops are the same.
So
this exponent is the same as that
exponent. Don't know
if
it's going to help yet. We're just playing around.
Okay, so that simplifies our equation a lot. So now we're just going to have that exponent,
and then at the bottom, usually if I see a 27 number that doesn't have a base of 3, I would make it easily. That's
very straightforward solving.
So 27, we can say that's
we can take that 3 across. And we were dividing, now we're going to
times that 3 to the minus 1, and again I'm going to split it like I did at the top. So I'm going to say 3 to the power of minus 1 and 3 to the power of x. Okay, that works because if we've got exponents, if we are adding them like this, we can also just say we are timesing the 2 like that. Let's see now if there's anything else we can do. So all that's left, I would say, is that we could
2.2.
We've got an inequality that we need to solve.
We've got a common
factor. So solving inequalities is exactly the same as solving an equation. So let's take that out. That usually helps us to do some
that inequality symbol in there. Okay,
so
we're just going to treat it like
at the top.
Just pretend that is just an equal sign.
3 to the power
we'll just solve it like usual.
The first term,
okay.
And just
so what we're going to have here is we're going to solve for x. So the first thing we want to do is try to get
let's just rewrite it, reorder it.
So we were dividing by 2. When we take it across, we're going to times it by 2.
3 to the minus 1.
So we're going to end up with x.
So now we're ready. We're making some progress. We can cancel these. So we can cancel
so minus 2 times 2 is minus 4.
At the top,
and exactly the same. We keep going. So we just treat this like an equal sign. So I want to get the x by itself. So I want to take that positive 5 across.
We can use our exponent laws again to rewrite this.
5.
So
I'm going to get x
we can write
greater than minus 4
3 to the power
minus
5 minus 1.
Okay, which means that x is going to be
at the
greater
top,
than
3 add 1
minus
9.
is
going to give us 4. And at the bottom,
okay, so quite straightforward. They make it seem really scary with the inequality sign. Exactly the same as you usually would have done.
And then we know
you usually would have solved for x.
2 is just
x
9.
is greater than minus 9.
Pretty simple.
We then use this information in the next question. So they say, so if x is a real number, so that just means it could be any number. So it could be 1.1 or 1.5, so it could have decimals in it. If x is a real number, represent the solution on a number line. So we've got this number line. We know that x is greater than minus 9. So we are going to start at minus 9. We're going to draw an open circle because it's greater than, it's not equal to. Okay, so we draw an open circle. X is every number that is bigger than minus 9. So we just draw an arrow every number bigger than minus 9. That would be our x, and we're just going to label our number line and just say these are all the values of x. Next up, we've got 2.3, which is a simultaneous equation question. It looks a little bit different because usually we expect simultaneous equations will have two equations that we can use. We're going to try just play around. If you get into the situation in an exam where you see a question like this, you just got to play around to see how you could get it so that you could solve for both. So what I would say, first of all, the thing that sticks out for me is these brackets are really, really similar. Okay, so they are quite close to being the same. X minus 3, 3 minus x. So what we can do and what we used before is we can actually change the order of the brackets. Okay, so let's keep that first bracket as is. We could rewrite this as x minus 3, okay, because that will help us create a common factor. If we change the order in the brackets, what we have to do is change the sign in front of the brackets. Okay, this is already looking better. Now we can take out these brackets as a common factor. So let's take the brackets out. So we've got x minus 3 as our common factor, and then we write what's left. So if we've taken this bracket out here, all that we've got left in the first term is just x. And if we've taken the second bracket out as a common factor, all we've got left for that second term is negative y, and that is equal to 0. And then we can see this has helped us a lot because it's gotten us to this form where we said before, if something times something is 0, it means that one of these has to be 0. Okay, so either this first bracket is 0, so x minus 3 is 0, or the second bracket is 0, so x minus y is 0. So if the first bracket is 0, then that means that x is equal to 3. Okay, so we've already solved for x there. And if the second bracket is 0, then that means that x is equal to y. And that is actually as much as we can solve for these two. So we've solved for x and we've solved for y. That is exactly what they asked. A little bit different to our usual simultaneous equation, but it's just showing if you get into this situation in the exam, just play around with it, see what you can do to it, and then hopefully you'll get an answer out of it like we did here. If we look at the final question or the final part of question 2, we've got a pretty lengthy word problem. As soon as you have a word problem, we know it's on this front page, so it's an algebra question, so we know we're going to have to say let x equal something. Okay, so let's have a read through. During a fundraising event, only 10 Rand, 20 Rand, and 50 Rand notes were collected. In the final count, there were twice as many 20 Rand notes as there were 50 notes. Okay, so let's see if we can maybe get a highlighter there. I don't think so. And there were 15 more 10 Rand notes than 50 notes. Okay, so let's start with that. So we can see both of them, we're comparing the 20 to 50, and we're comparing the 10 Rand to 50 notes. So let's make x be 50 Rand notes. Okay, so x is 150 Rand note. That means, well, we don't need to say let's again, but we can put 20 Rand notes and 10 Rand notes in terms of this x. Okay, so 50 Rand notes is x. They say there's twice as many 20 Rand notes. Okay, so the 20 Rand note, they are twice as many, so they are 2x. And then the 10 Rand note, they say there are 15 more than the 50 Rand. Okay, so the 50 Rand is x, and there are 15 more 10 Rand notes. Okay, so this is always the first step. In one of these lengthy word problems, we've got to put everything into this form of x's. So we know we have x 50 Rand notes, we've got 2x 20 Rand, and we've got x plus 15 10 Rand notes. Now they say, if 10,150 Rand was collected in total, determine the number of notes that were collected. Okay, so we're going to say, if I have the total value of these, it gives me 10,150. Okay, so what we've got to say is we've got to say, okay, my 50 Rand notes, I've got x 50 Rand notes. Okay, so x times 50 Rand notes. So that means I've got 50x. Okay, that's how I'm going to write it when I actually put it into this equation. Okay, because that will give me my total. My 20 Rand notes, I've got 2x times my 20 rand notes. So that means I've got 40x. And then my 10 rand notes, I've got x plus 15 of these 10 rand notes. So x plus 15, we're going to times that by 10 to get the total value of those 10 rand notes. Okay, so 10 times x is 10x. 10 times 15 is 150. Okay, so now I've got it into this form. The reason why we're doing this is we're working out the value. So if I said to you, I've got 10 50 rand notes, I could say then x is 10 times 50. So that would give me 500 rand. That would be the value of those 10 50 rand notes. So if you put this all into equation, we've got 50x, add 40x. Okay, so that's our 50 rand notes. That's our 20 rand notes. And then we've got to add our 10 rand notes. So I've got 10x plus 150. And all together, if I work all of these out, I'm going to get the total of 10,150 rand. Now it's just a case of then solving for what x is, so we can know how many of each of these notes we have. So what I would say is we add these x's up first. 50 add 40 is 90, add 10 is 100x, plus 150 that we still got there gives us that total. We want to get x by itself, so we're going to take that across, take away the 150, so 100x is this 10150, take away the 150, so it's just 10,000. And then 10,000 divided by that 100 is going to give us x is 100. Okay, so if we look back then at our let x be this and let y 20 rand be this, we can see then x is how many 50 rand notes. So we've got 100 50 rands. Okay, 150 rand notes. That means we've got double that for our 20 rand. So we've got 200 20 rand notes. And that means we've got 100 add 15. So 115 10 rand notes. So we can see then that is exactly what they asked for. We want the number of these notes that were collected. So we can see I've got 150s, I've got 220s, and then I've got 115 10 rands. I really hope that was a helpful video. If you have any questions, anything you want me to answer, please let me know in the comments, and I will work through the rest of the paper in another video.